Welcome.
So, dear colleagues, today we present our talk, head-up display for forest machine based on laser diode DLP engine. So, some words about us. We are from ITMO University. This university is leader in optics and photonics technologies in Russia. Our main activities are education in optics and R&D. So at this conference, we present a small company, Applied Optics Design Bureau, and we deliver R&D and commercialization of innovations. Also, we are residents of ITMO University Technopark. So also we present Technopark at this conference. And then our talk will be continued by Dr. Anton Filatov, specialist in head-up displays.
Good afternoon, ladies and gentlemen. I would like to thank you, Marina, for introductory word. And I will focus on some technical aspects of new head-up display. Recently, our team is working on development of new head-up display for aviation application. Historically, the main problem is that all the head-up display for planes were based on cathode ray tube as a device which formed the image for projection in the front of the pilot. At the present time, this cathode ray tube became commercially unavailable, and all the people dealing with head-up display for avionics are looking for the new solution which may provide the same brightness as was provided by cathode ray tube. And we have done some progress in that field, and we have developed new DLP engine based on green laser diodes. But now I would like to discuss with audience our idea how to bring this technology from avionics to the forestry. Yesterday and today there was too many reports regarding forest machine, so I will not focus on what is a forest machine. This technology called synthetic vision system, this is a kind of augmented reality for an aircraft. This system improves situational awareness of the crew and significantly expand the weather condition in which the plane can fly and can be landed. This system displays a synthetic image which may be combined from special characters and signs, as well as the image captured, for example, from thermal camera and 3D Earth map. You can see typical two image from head-up display. This is image with special characters in weather condition when you cannot see anything behind the window. And in that condition, actually you cannot land an aircraft. But if you combine this image from the image captured from thermal camera and from computational map, you can see the runway and you can land an aircraft. Our idea that we can implement the same approach in forest machine and expand weather condition for forest machine, and it may result in improving of efficiency and safety of using of forest machine. Our colleagues from Sweden, company Optea, announced their system Forest Falcon. They announced that system will be launched this year, and they called the system Forest Falcon. This is a head-up display for a forest machine. Several years ago, our team have made an optical design for that system, and on this picture you can understand what does mean head-up display for a forest machine. On the left picture you can see the positioning of the operator relative to head-up display, and on the right you can see which image you can project in the front of operator to make his work more efficient. But head-up display itself is just another one display in the cockpit, and it's not useful. It became useful when it's combined to so-called synthetic vision system, when you combine, for example, thermal imaging with imaging of special characters and display that synthetic picture in the front of operator. The system can be easily integrated with some kind of calibration system, which result in operator may decide which trees is better to cut down, for example. And I expect that thermal imaging is a good tool for diagnostics of the trees on site. We are based on research that have been performed by Forestry Research Institute of Sweden, and they found that the operator spends approximately 20% of time looking at the instrument panel, and this is a lost time for harvesting. That's why we expect that implementing of head-up display in the cockpit of forest machine may improve efficiency approximately up to plus 20%, because it provides more less fatigue factor for operator, and it will increase efficiency and safety of the harvesting process. So what's innovative in our proposal? We propose a complete solution which starts from thermal sensor and ends at the displaying of synthetic image in the front of operator. On top of that, we have developed new light engine which provides compact design, less heat dissipation and brighter image. And we are based on freeform optical parts which provides more ergonomic design in the cockpit. Freeform surfaces provides more degrees of freedom when you make optical design, and it results in you can use the less number of optical parts in optical system, which result in more ergonomic solution, which will be more convenient for the operator. And what is a light engine? This is a small projector. This is a small replica of the beamer used in this auditorium. And this light engine provides initial image, which is then projected by optical system in the front of operator. Traditionally, this system was based on DMD chip. This is a micromirror array. But our research showed that more promising are small LCD screens and so-called FLCOS chips. This is ferroelectric liquid crystal on silicon chips. And our idea is to change traditional high brightness LED for illumination of the chip to laser diodes, because they provide much more brightness and provides less heat dissipation. In the end, we can go to the very compact design of this projector, which result in more compact design in the cockpit. We made some mock-ups, and we can say that we are providing 150 candle per square meter. This is a value of brightness which is comparative with cathode ray tube. And based on that, we can provide the brightness approximately 30,000 candle per square meter in iBox. And in having such brightness, the operator may work even with background of bright sky, not only with background of forest. And on this slide you can see two pictures. This is intermediate image located formed by DLP engine with green laser diodes. And this is a resulting image from head-up display. However, this picture was taken from the vault of avionics, and this is a picture for avionics. We would like to bring this technology to the forestry, and we are looking for the partners in Finland to make this project feasible. So thank you very much for your attention. If you have any questions, please ask me.
Thank you. All right, questions?
Briefly, can you still somehow define what is the kind of maturity? How close it is to commercial impact?
So the question was about maturity of this project. How close are you to commercialization, commercial product?
In principle, we are close to commercial product. I expect if we will expand our activity with Aptea company from Sweden, we can redesign the Falcon Forest system and to make some new prototypes to show to forestry society, and then to continue this work. So I think we are not so far from commercial product. At least I can say that this product is very close to mass production for avionics. And avionics is requires more strict requirements to the system relative to the forestry.
Yeah.
Because the safety in aviation is more important factor than in the forestry.
Yeah, there are more people lives involved. Yeah, that's true. Do you have any estimate what would be the price for the final product?
I expect the final product shall cost approximately several tens thousand euros.
10,000 or more?
I think in the range from 50 to 100.
From 50 to 100,000?
Yes, but I'm talking about the complete system with thermal cameras
yeah.
and with calibration system and with head-up display system.
Yeah. Okay.
Now the main idea that is head-up display itself, this is just another one indicator. It became useful only in combination with thermal camera and additional sensors.
Yeah.
And with computer which will form the image will then project in the front of operator.
Yeah. I guess in 10 years time we will all have some kind of augmented reality glasses, so the augmented reality and HUD displays will be everywhere. I just received, before I left here on Tuesday, I received my HUD display for my car. It costs 69 euros. It's a small American company producing them and selling them on the web, and it's only a display. You put your own smartphone in front of it, and it displays the map and the driving direction from the smartphone in front of you, on top of the dashboard. So it's very cheap. so in the future, I guess these types of products will be very common in all vehicles, be it aircraft or passenger car or harvester or whatever. Any more questions? Over there.
Just to understand, the thermal image, how is it presented? Not on the hood?
Yes.
So how is thermal image displayed?
Because you see something and then you see the thermal image, how to get them in the same place in your vision. How does it show on the
just image the situation when such image is combined with that image, and when you look in through head-up display, you can see the tree with unaided eye, and at the same time you can see the thermal image of the same tree via head-up display.
at the same position. Yeah. Okay, so you get the position so you see both at the same time.
I guess it requires some additional experiment. What would be better for operator? And I expect that the system shall provide the possibility to choose for operator which picture he can see via head-up display.